Okay, this is a tutorial for how you're going to actually wire up your motor. So I've got some wire here, I've got my connector, I've got my motor, and I'm going to attach the wire to the motor and then to the connector. So I have 22 gauge wire that I cut off of this spool here. And as you'll notice, there's a red strand and a black strand. So this wire is intended to be used for power. So the first thing I'm going to try to do is solder the wire to the motor. And to do that, I need to actually strip some of the wire bare to prepare it for soldering it to the motor terminals. So it's 22 gauge wire, so I'm going to find the 22 gauge hole on my wire strippers and put the wire in there and strip off about a 1/2 inch on both the black and the red wire and twist it up just to keep it nice and tidy. So now I'll strip off the 1/2 inch off the red wire. Okay, and so I want to solder this thing to the motor, but if I just try to twist it around the terminal and then kind of add a glob of solder onto the wire and the terminals all at once, it won't work that well. So what I should do instead is actually do what's called tinning the wire, which is to kind of melt some solder onto the wire by itself before I try to solder it to anything. So when you're soldering, if each of the two parts is already tinned, it's just a matter of heating them both up in order to get the solder joint to form. Okay, and you'll notice that I'm putting my soldering iron in these brass filings here. That helps to clean it off, keep the tip free of oxide, and make it nice and easy to melt solder. So now I'm just going to tin the two motor terminals as well. So this is just the process of kind of getting a little bit of solder on there. And these terminals have holes in them, so you might find that you melt a little bit too much solder onto the terminals, and then you kind of need to remove a little bit. In that case, you can use something called desoldering wick, but I'd advise you just to go easy with the solder on the terminals, because you actually want to be able to insert the wire into the holes on the terminals. Okay, so that's finished now, and what I'm going to do is actually take the power wire, insert it into each of the motor terminals. I'm going to spread it out a little bit. Oh, but before I do that, I actually need to put some heat shrink on it. So heat shrink is really useful because it protects sort of bare connections so that it's harder to short them out. And what it also does is it provides a little bit of strain relief. So if you wiggle the wire back and forth, it makes it a little bit stiffer so that you can't bend the wire repeatedly as easily, which would eventually cause it to break off. So heat shrink is always a good idea on any kind of bare connections. So I'll just insert the wire into the terminals here, and I'm kind of just bending it up with my fingers. So this is another good reason not to get too much solder on the wire. If you get a whole gob of solder on the wire, you won't be able to bend it at all. So I'm just kind of bending it into a loop after inserting it into the terminals. And then all I have to do now, since the terminal was already tinned and the wire was already tinned, I just have to get it hot. But I'm going to add just a little bit more solder into the whole thing to make sure that it's super sturdy and really well connected. So in general, I don't advise using solder as a mechanical element. That is, you shouldn't rely on the solder to provide the mechanical joining force. So that's why we bent the wire into a loop after we put it through the terminal. The solder should really be considered an electrical connection, and you should provide some other form of mechanical connection. So I slide the heat shrink down over the terminals, and I've got my 1500 watt heat gun here, and I'm just going to turn it on low. I don't need to do much more than that. And as I blow the hot air on the heat shrink, you can see that the heat shrink is actually shrinking as we would expect, and kind of forms a conformal coating around our solder joints. So that's handy. It'll make them a little bit more robust, less likely to short. Now we actually need to strip the other ends of the wire so that we can put our Molex connector on. And again, 22 gauge, so find the 22 on your strippers. If you refer to the handout on the course website, we only need to strip about 1/8 of an inch off for these Molex connectors. So we're going to crimp on what are called crimp terminals. And the crimp terminals have sort of two sets of tabs that bend around the wire, and the insulator bite in and form a connection. So I'm pointing here at the conductor portion of the tool. So that is for crimping the smaller tabs that form around the bare portion of the wire. I'm actually going to start instead with the insulator portion of the tool, so that's closer to my hand here. And for this particular gauge, 3.4 or 3.6 should work just fine. So the way to do this is to get the tabs that are going to bend around the insulator situated inside of the crimper and kind of hold the crimp terminal in the crimper, insert the wire, get it aligned so that the insulator tabs are aligned only over insulator and the conductor tabs are aligned only over the bare wire, and then crimp the insulator tabs with the 3.4 or the 3.6 setting. On the conductor, you'll want to use the 1.4 or 1.6 setting. These tabs are a bit smaller, and the idea is that these tabs, the crimper causes these tabs to kind of bend around and inward and bite into the wire, creating a good, reliable electrical connection. So the insulator tabs are primarily for strain relief. They keep the wire and the crimp terminal from separating. And the conductor tabs are primarily for your electrical connection. So I'm just doing the same thing here again on the red side. Insert the wire. I guess I'm holding the crimper in my dominant hand this time, makes it a little bit easier to apply the crimping force. You don't need a ton of force to bend those tabs around and form a good mechanical connection with the insulator. And I'll crimp the conductor portion of the crimp terminal. And the only thing that remains to do is to insert these crimp terminals into my Molex connector. So I actually want to insert them in the back side so that when they come out of the shrouded side, they're surrounded by the sort of plastic edge. And so I'm just pushing those in. There are little tabs on the sides of the crimp terminals that kind of snap across an edge and snap into place when it's all inserted, so you can't actually pull the wire back out. Got my handy dandy test power here. This is a 5-volt supply, and all I'm going to do is plug in my test power to the motor, and I think we can see there that the shaft is actually spinning, and so we have success in wiring up our motor. And that's really all there is to it.